How do I solve it? What do I do? If I distribute, that's going to take me back to what I had here. So I don't want to distribute. I want to solve for x. I'm trying to get what are the values of x. What do I do once I have it in factored form and it equals 0? Okay, and you're actually going to make both of those parentheses equal 0 because this was your zero product property that you guys should have learned in Algebra 1 that says if two things multiply and the product is 0, the only way that's possible is if one of them is 0. So either x minus 3 has to equal 0 or x plus 2 has to equal 0. And then from there you just solve for x. Add 3, so x is equal to positive 3. Or subtract 2, x equals negative 2. So your two answers should have been for the first one 3 or negative 2. Okay? You can also do that by the quadratic formula. So I'll work the second one with the quadratic formula, but if I were going to factor the second one, just so you'll know, this should factor into x. Factors of 12 that give me negative 7 would be negative 4 and negative 3. So the answer here is going to be positive 4 or positive 3 if you go through and work it with the factoring method. But I'll work that one by quadratic formula since a lot of you were working it that way. Okay, so you guys learned the quadratic formula. The quadratic formula has A's, B's, and C's in it. Those A's, B's, and C's are the coefficients that are in front of your variables and your constant at the end. A is in front of the x squared, B is in front of the x, C is the constant. So if we solve the problem that we have over here where we have x squared, what was it, minus 7x plus 12 equals 0, what is A? Careful. A is the number in front of the x squared, which is 1. What is B? Negative 7. And what is C? 12. And then you can plug that in. But again, you're going to have much bigger numbers and a lot more work that you're going to have to do and a lot more chance for mistakes without a calculator using the quadratic formula. If it's factorable, so much faster to factor if you can remember or understand that guess and check idea. So opposite of negative 7 is positive 7. Plus or minus the square root of negative 7 squared minus 4 times 1 times 12. And all of this is divided by 2 times 1. Okay, then we simplify. We have 7 plus or minus the square root of 49 minus 48 all over 2. 49 minus 48 is 1, and the square root of 1 is 1. So we have 7 plus or minus 1 over 2. Then you need to do that. What is 7 plus 1 divided by 2? What is 7 minus 1 divided by 2? So the answer is 4 or 3. Okay, my goal here is that you have either figured out, 1, you do not remember how to solve a quadratic and you need to come in and get some extra help, or 2, you know how to solve a quadratic by factoring and you feel good about that, but you don't remember quadratic formulas, so you need to come in and get some help because factoring doesn't always work. Or 3, you remember how to solve by quadratic formula, but you don't know how to factor and you want to come in because you like that it's faster. Or 4, you got it either way, you're good to go, you don't need to come in at all, okay? But I promise you, you will see quadratic equations on every test, well, I should say on most tests throughout this school year. So it is something that you do not want to walk out of here and not get back in here as soon as you can to get some extra help with because it will cost you points and a lot of points over the course of the semester, okay? All right, I'm done with quadratics for bell work, but if you need help, be sure to come see me. All right, so we're going to jump right into 1.7, which is our last section of Chapter 1. These will be your last vocabulary words today. I'm going to ignore this part up here. It's just kind of some FYI for your information. Starting with our definition for transformation. So today, this section kind of just gets thrown into chapter 1. There's not a whole lot of connection to what we've been doing, but it is kind of a basic skill that they think you have seen before and you need to know how to do before we move on to the next chapters in the textbook. So there are 3 transformations we're going to talk about today: reflections, rotations, and translations. Tell me what a reflection does to a shape. So what is that? Flips it, okay? What does a rotation do to a shape? Turns it. What does a translation do to a shape? Okay, it moves it, so it's going to slide it left or right, up or down. Raise your hand if you've heard those words before. Okay, this section is going to be just kind of a brief overview and should be pretty simple, with the exception that I'm going to throw in some Picky Lashley details and some information that maybe you haven't quite seen before. But for the most part, it's just kind of a big overview of those 3 transformations. Be careful you don't confuse transformation with translation. If you read that word too quickly, you might confuse those. Transforming is what we're doing to our shape. We're going to move it. In this class, in the first chapter, the only thing we're going to do is change the position. Okay, so we're just going to move the shape around, whether it's flipping it, turning it, or sliding it. We will not change the size of our shape yet. We will eventually. What transformation changes the size of a shape? Does anybody know what it's called when it gets bigger or smaller? Your eyes do the same thing when they get bigger or smaller. Dilation. So dilate is what your eyes do. A dilation is a transformation that makes it bigger or smaller. We are not talking about dilations in chapter 1. A transformation could change the shape of your figure, but it will not in this class. Anytime that we ever take a shape and we transform it, it's still going to be the same shape. It's going to move, and it might get bigger later or smaller, but it's never going to change from a triangle to a circle or a circle to a square. Okay, it's going to be the same shape. The original figure will be your pre-image. The resulting figure is the image. So you're going to start with the pre-image. The result's going to be the image. This part is the picky part that I want to make sure you may not have seen or been required to do. So they're going to use this word maps. They're going to say the transformation maps the shape onto another shape. What that means is, got a mess on my board here. Okay, what that means is if you have a triangle here, A, B, C, and then you reflect the triangle across this line, and you get this new triangle, pretend they're the same size, what would this point be? Okay, and they're going to tell you that you're going to use prime notation. Have you guys seen prime notation before? Some know. So prime notation is an apostrophe, C prime. It denotes that this is the image and this was the pre-image. Okay, so we would call this point B prime, A prime. And if it's a reflection, this has to be C because the distance from the pre-image point to your line is going to be the same distance from the line to your image point, right? Okay, so what they're going to say is this transformation of a reflection maps triangle ABC onto triangle A prime, B prime, C prime. And they're going to use what's called arrow notation to show that. And this is super basic and super easy, and every year it's the thing that people miss on their homework because it's like, why do I even need to do that? But if it says, write the arrow notation, this is what it means. Triangle, ABC, arrow, this means maps onto, triangle, A prime, B prime, C prime. This is arrow notation. And on your homework, they're going to ask you to do that. Okay? Super important that you understand that that's arrow notation. Maps onto means this point A is going to land on A prime. This point B is going to land on B prime. They're going to ask you questions on the homework about what is the pre-image of this point or the image of this point. So for example, what's the pre-image of C prime? C. What's the image of B? B prime. Does that make sense? Okay, so this is mapped onto this. This is the pre-image. This is the image. It's all listed right here, kind of the same thing. We've got a pre-image. We've got an image. There's prime notation. This is your arrow notation. If I were you, I would write that down on your notes because you're going to get to the homework and forget, what did she say arrow notation was? That's arrow notation. It's nowhere else in your notes as far as listed. Okay, when you get to the homework, some of your problems are going to be on graph paper. You must do it on graph paper. Make sure you get some graph paper if you don't have some today before you leave. Some of your problems are just going to be like this, where they're a picture and they're not on graph paper. If it is not on graph paper, you do not have to get specific with your answer. If it's just something like this and it says, what is this transformation? You could tell me, what kind of transformation do we have here? Is this a reflection, a rotation, or a translation? Translations. Everybody agree that we're just taking this and sliding it this direction? Okay, so if it's not on graph paper, you're just going to tell me translation. That's it. Simple, easy. Got it? If it's on graph paper, then I'm going to get super picky. So this is if it's on graph paper, or if you're on a coordinate plane, okay, XY axis. If it's on graph paper, there are going to be some specific details that you have to list for me on every problem when it says identify the transformation. Starting with a reflection. You will not call it a flip. You will call it a reflection. Flip, turn, slide are now our baby words. We're going to use reflection, rotation, translation. A reflection is a transformation that goes across a line. That line is your line of reflection. When you tell me it's a reflection, you must list the line of reflection. Sometimes that's going to be the x-axis. Sometimes that's going to be the y-axis. Sometimes it's going to be a diagonal line, and you're going to give me the equation of it. Sometimes it's going to be a vertical line that's not the y-axis, or a horizontal line that's not the x-axis. So let's review some Algebra 1 here again. We've already said this is x, this is y, right? What is the equation for this horizontal line? So what is it? X equals -3, do you agree? Okay, it is a horizontal line, and when you think horizontal, you think x-axis, and the most common mistake is to say x equals 3 because you're thinking horizontal x, right? But notice x changes all the time. 1, 2, 3, so I've got to point out 1, -3, 2, -3, 3, -3. X can be anything, but y is always what? -3. So if it's horizontal, it is y equals a number. You may want to list that in your notes if you have forgotten that. Horizontal is y equals a number. So therefore, if I gave you a vertical line of reflection that was not the y-axis, so for example, this one here, what would be the equation of this vertical line? X equals 1. Because x is always going to be 1 here, but y is constantly changing. So if it's vertical, the equation is always x equals a number. You guys remember that from Algebra 1? Okay. And if not, write it down so you'll remember for your homework. So if you have a picture on a graph and it says, what is this transformation? You're going to say, it's a reflection across whatever the line is. It may be the y-axis, it may be the x-axis, it may be the line x equals 2, whatever it is. Rotation, you're not going to say turn. It is a transformation about a point. That point is the center of the rotation. If it's on graph paper and you say it's a rotation, you have to give me the center of rotation. Now, it's going to be really easy for this first section. Every time in the first section, the center will be centered at the origin. So you won't even have to guess what it is. You'll know for this first chapter, it's always going to rotate about the origin. They'll get harder later. We'll move that point somewhere else. But for right now, we're going to say the center's at the origin. Okay? That's not all you have to tell me. If it's a rotation, you also have to tell me the direction that you're rotating. Do not say left or right. When you rotate, what words do you use? If we're going to the right, what word do we call that? Clockwise. If we're going left, we call it counterclockwise. So rotations you're going to describe as clockwise or counterclockwise. And if you forget, look at the clock. Clockwise versus counterclockwise. And then you have to also tell me, so the third thing you have to tell me is the angle of rotation. Now, again, I'm going to keep it super simple for the first section. They'll get harder later. Your angle of rotation, if it's on graph paper, will be an increment of 90. So 90, 180, 270, be pretty easy to tell. But if it wasn't, so this is not for this homework, but for later, if you weren't quite sure what is my angle of rotation, here's how you can find it. You're going to go from the pre-image point, just pick one. I'm going to use G here for an example. Draw it back to the center of your rotation. So what's my center of my rotation for this problem? Point P. For any problem that's on the graph, it's going to be 0, 0. But for this problem, it's actually point P. Then connect that back to your image point G prime. The angle that's created is your angle of rotation. So if you're ever unsure, draw that and then either measure it with a protractor or look at it and see, does it look to be 90? Is it a straight line so it's 180? Or is it bigger, it's 270? Okay? All right, last one, translation. You're not going to use slide. You're going to say it's a transformation. All the points of the figure are going to move the same distance in the same direction. So those are the two things you're going to tell me if it's a translation. You're going to tell me distance, and you're going to tell me direction. For example, you might say you're going to shift it right 2, down 3. Okay, so direction and distance. If it's on a graph, you have to list the specifics to get credit. If it is not on a graph, like the problem before, you don't have to tell me anything other than translation, rotation, or reflection. Okay? So first example. It says, identify the transformation. Then it says, use arrow notation to describe it. Are we on a graph? Yes, so you have to give me specifics. So look at your picture. What does this, first of all, which shape is the pre-image? Blue or red? Blue. We know because the red has what? Primes, okay? So we're trying to go from blue to red. How do we get from blue to red? Reflect, translate, or rotate? Everybody thinks rotation? Okay, if you're not sure, you can always get a piece of tracing paper and trace your shape and then physically slide it or flip it or hold your pencil at the origin and turn it and see, does it land on top of each other? Okay, but it is definitely a rotation. So now what are all the things you have to tell me? It's a rotation about what? Mm-hmm. As well as give the center of rotation. All right, so what is my center? What am I rotating about here? 0, 0. Or you can say origin. It's a rotation about the origin. What's the direction? Okay, we're going to go from blue to red, so we could go the shortest way to the left, which is counterclockwise. And how far? Okay, so remember, I'm going to keep it pretty easy on the first ones. It's going to be increments of 90. So when we look at this, if you're not quite sure, remember the trick you can use. Draw in your origin. Pick one of your points to start with. I'm going to choose A here. Go from A to your origin, and then from your origin to A prime. Does that look like a 90-degree angle? Okay, and if you weren't sure, you could take a protractor and measure it. You don't need to do that, though. It's going to be increments of 90 for this first section. So it's a rotation about 0, 0, counterclockwise, 90 degrees. Could I have said clockwise? Mm-hmm. But I would have to say 270. So you could actually go either direction, but it's going to change your angle. So instead of going to the counterclockwise direction, the shortest way, I would have to go clockwise the longest way, which is 360 minus 90 or 270. But I'll accept either answer on your homework. Okay, last thing is, what does it say to use to describe? Arrow notation. So remember, when you do arrow notation, you're going to name the pre-image. It is a triangle ABC. And then you're going to use that arrow, which means maps onto. And then you're going to name the new triangle matching up your points. So it'll be triangle what? Should be really simple, right? That's just arrow notation. It tells you what the pre-image will land on with the image. Sometimes they won't use the same letters. They'll use different letters. Most of the time they use prime notation. But sometimes it'll be ABC maps onto DEF. So it just depends on what's in your picture. All right. Let's look at the next one. We'll go a little faster here, maybe. Okay, what do you guys see here? Heard reflection? What do you mean by placed in different orders? Okay, so what does that mean that it can't be? Okay, it can't be a translation for sure, because if I just translate it down, E is not going to land on E prime when F would land on F prime, right? So it has to be a what? Reflection. What do you have to tell me if it's a reflection? Okay, what is the line of reflection here? It's a reflection across what? So you're either going to say x-axis, y-axis, or you're going to say x equals a number, y equals a number. I don't know why I put 11 there. Okay, so you could say x-axis, or you could say exactly what Levi said. X-axis is the same as y equals 0. And I don't care either way. Does not matter. All right, and then arrow notation. The only shapes that we will put an actual shape in front of when we name them are triangles and parallelograms. Everything else in the textbook, they will just name the shape with the capital letters around the figure. Make sure that you go consecutively in a circle, either clockwise or counterclockwise. Never name this as shape DEGF, because then you're writing a Z, right? So you have to make sure that when you name it, you go either clockwise consecutively or counterclockwise consecutively. So how do you want to name it? Thank you. I'm very alphabetical. That helps me out a lot. DEFG, arrow, and then it would just be D prime, E prime, F prime, G prime. There's your arrow notation again. You don't have to put a symbol in front of it. And parallelograms will come later when we're talking about parallelograms. They do that to make sure you're aware that your shape is a parallelogram. But right now, really, triangles are about the only thing that we'll be putting a symbol in front of. Okay, this is different because this is no longer on graph paper. So all you have to do here is tell me what kind of transformation is it. So don't make this harder on yourself when you get to the homework. What does A appear to be? Translation. What does B appear to be? Okay, so we're trying to get this blue shape to land on this red shape. If I reflect it across a vertical line or across a horizontal line or even across a diagonal line, it's not going to land on top of red. Do you guys see that? So it is just a rotation. I think we've got arrow notation down, so I'm just going to show you the answers here instead of writing it all out. Are we good with that? Feel free to write down the answers if you want to, but that's all I'm looking for on those kinds of problems. So you don't have to tell me the line of reflection, the direction, the angle of rotation, any of that information. So make it easy on yourself. Okay, I think the next two problems on your notes. On the homework, they will not provide you with a graph. But on your notes, I provided you with a graph, right? I did that to save us time so that we didn't have to get a piece of graph paper, plot all the points, connect them, draw the pictures. That would take a little bit more class time. So on the homework, I'm assuming that if you're given this information that you can graph those shapes and connect them. I don't know why, but every now and then I'll have a student, when this is the homework question, and it says draw the pre-image and image, they do this. And that's all they do on their graph. That will not get you credit, okay? When it says draw the pre-image and the image, there's two things I'm going to be picky about. One, it's a shape. Connect the dots. Two, label them with the correct capital letter for the points. So if this were A, B, and C, and this were A prime, B prime, C prime, make sure you're putting the prime notation to indicate which one was the pre-image and which one's the image. Okay? So if it says draw, you have to have graph paper, you have to draw them. Then it just simply says, part 2, identify the transformation. So I sped this up by graphing it for you on your notes. Let's just identify the transformation. What do you see here? Reflection across y-axis, or x equals 0. Correct. So it is a reflection. They write a whole lot of words you don't need to write. Reflection across the y-axis. Look at the last one that's there before we move on to, so look at this one. Again, it said draw it, so you'll have to graph it. Now what do we have here? Rotation. Give me all the specifics. Okay, rotation, 90 degrees, what direction? Clockwise. Is it 90 degrees clockwise or 90 degrees counterclockwise? Okay, so look, which shape is the pre-image? Okay, this one down here, right? Lower one. So if I want to take this shape onto this shape, and I only go 90 degrees, E to origin to E prime, that's 90. What direction am I going? Counter. So if I say clockwise, I have to say how many degrees? 270. Okay, so make sure you identify which one's the pre-image or that'll mess you up, right? So we're going this direction. So it is a rotation, 90 degrees, counterclockwise. What are we missing? About the origin. I'll be picky about that because later it's not going to be about the origin, and that changes everything, okay? So it is a rotation, counterclockwise, 90 degrees, about the origin. All right, the last thing that's in your notes for today is writing rules to describe these transformations. In section 1.7, the only rule that they talk about is for translations. When we get to chapter 4, we're going to be writing rules for all of them. Rotations, translations, dilations. We'll be doing all of them. But for this first section, they just introduce you to the idea of writing a rule, and they do it for translations only. I'll be picky about this. So I sound like I'm super picky, but I'm just trying to stop you from getting points taken off your homework, okay? So when you're writing your rules, you must start with X, Y, arrow. That's the one thing I see students forget to do when they write their rules. So make sure every rule starts with X, Y, arrow. What comes next depends on what the transformation is. So think about a translation. What does a translation do? Okay, moves it what? How? Okay, it's going to move it across the plane. So it's going to go left or right, and it's going to go up or down. So when you take your coordinate, what we're saying here is that each point on your graph is going to be mapped onto a new point, and that new point can be found by this rule. So if you are shifting right or left, then what you're going to do is you're either going to add or subtract something to your X value. If you add it, what direction would you be going? If we're talking about X, you would be going right. If you subtract it and you're talking about X, what direction would you go? Left. Okay? And if you're shifting your shape up or down, that's going to be adding or subtracting something to your Y value. So if you add, what direction are you going? And if you subtract, down. Okay? So they're going to give you rules and ask you to do the translation, and they're going to ask you to write rules on your own. So for example, if you look at this one, you're going to know it's a translation even if they don't tell you, because what they're saying by this rule is to take each point and map them onto a new point by adding and subtracting. And if you add or subtract, that means you're shifting left or right, up or down. So you're translating your shape. So by the time we're in chapter 4, you should be able to see that rule and automatically know that's a translation. Okay? What is this telling me to do? Right 2, down 1. So worst case scenario, this is not what I would do if I were you. You could list the coordinate for point A. Where is point A right here on the picture? Careful. Negative 4, 2. And what this is saying is if you were to plug negative 4 in for x and 2 in for y, that will give you the new point for A prime, right? Okay, the faster way to do that is just simply to take A and shift it right 2, down 1. I'm going to use a different color. Right 2, down 1. It does say draw the image, so you're going to have to draw it anyway. So list it as A prime. It says find the coordinates. So on your homework, I will not just be grading your graph. I'll be looking, did you list the coordinates for A prime, B prime, and C prime? Okay, so let's go ahead and do that for all of the points. This says right 2, down 1, right 2, down 1. B is going to go right 2, down 1. And C is going to go right 2, down 1. Where are my coordinates for A prime now? Very good. Negative 2, positive 1. Where are the coordinates for B prime? Negative 1, 3. Where are the coordinates for C prime? Positive 1, 0. So if this is a question on your homework, you're listing your coordinates, you're graphing your shape, and what have I not done yet? Connect the dots. So don't forget to go back and make your shape look like a triangle. Easy? Okay, we're not going to do the next one, but let's just talk about what the rule says is going to do to the picture. So look at the next problem. What is this saying to do to our picture? Left 2, up 4. Is everybody understanding that whole idea? All right, last problem on your notes. They want you to write the rule this time. So I want you to go ahead, you and your partner, see if you can write a rule for this situation based on this picture. An answer and half of you that are still looking at it. Let's go ahead really quickly and just bring it back together. So it says write a rule for the translation of hexagon 1. So here's hexagon 1. I probably should have used a different color there. That did absolutely no good. Hexagon 1. And we want it to land on top of hexagon 2. So what I would do is just pick one of those vertice points and ask yourself, how do you get from one of those points to the other shape's same vertex point? That's why they identified this as A and A prime to kind of help you with that. If you take this point, you want to figure out how to make that point land over here on top of its same consecutive point once you were to slide it over. So there's A prime. So your rule always starts with what? X, Y arrow. Make sure that that's what you started with because you don't want to miss points for that. And it will still be X, Y. You don't plug coordinates in there when you're writing a rule. That means it works for every point in the shape, okay? The numbers come into play when you write the rule over here. So you're going to take X and do something to it, and you're going to take Y and do something to it. Sometimes you don't move left or right or up or down, and you just leave it X and Y. Sometimes you do move it left or right, and you add or subtract. So what are we going to do to get from A to A prime?
X minus 3.
Okay, so we're going to go left 3. Does everybody agree? So X minus 3, comma.
1 plus 1.
Very good. So we're going to go up 1.5. Notice that's not on a corner point. So we're going to estimate that that's at about 1/2, and we're going to do Y plus 1.5 or Y plus 1.5. Any questions on the rule? All right, and that's all there is to it, guys. You've got about 20 minutes. I want you to get started on your homework, or you can start making a Quizlet if you haven't done that since we're officially done with our vocabulary. And let me know if you need my help with